Most of the data held by an organization is stored in various databases. Access to this data is controlled and secured. Only authorized people and processes are allowed to add or modify this data. Data is shared with partners or the public deliberately in a controlled manner. That's the goal, at least. Most enterprises find themselves in a constant struggle to maintain their data, and it's quite a challenge. There are all kinds of people who might want to tamper with your data. There are hackers, of course. That's the one that gets most of the press these days. But organizations also have to deal with disgruntled employees, corruption, technical flaws, and human error. Still, every enterprise has systems in place to address these issues, with various degrees of effectiveness. If one asks, as one must, if the radically different approach of a distributed public blockchain might somehow magically solve these types of problems, it shouldn't take long to realize that the idea is completely ridiculous. Distributed public blockchains are great for shared data that has no one owner, but make little sense for the vast majority of corporate data. This leads to another question. If a public distributed blockchain makes no sense for corporate data, is there any way for blockchain technology to help address the overall problem of maintaining data integrity and security? After all, a secure and immutable ledger can be a very useful thing from an enterprise perspective, especially if you could build it on top of your existing technology stack and have it integrate tightly with your existing systems and data. The answer to this question is a definite yes, and the approach is a private blockchain. Now, I'm going to get into some trouble here, because my use of the term private blockchain in this course is not one that everyone will agree with. And since terminology in the blockchain world is often a religious argument, some of what follows will be considered blasphemy. I am sure to be yelled at, or worse. You see, when many people use the term private blockchain, what they're thinking of is a distributed private blockchain. It's a distributed ledger where access is controlled using cryptographic or other means. The idea here is that of a blockchain that is shared by cooperating organizations, or maybe even divisions within a corporation. Lots of companies are working on solutions and products to implement this type of private blockchain, sometimes also called a consortium blockchain. But in the vast majority of cases when discussing private blockchain, the focus is as much on the distributed part as the blockchain part. In fact, many people dismiss private blockchains as no better than a shared database. Come to think of it, many people just dismiss private blockchains, period. There are applications for fully distributed private blockchains, and perhaps I'll address those in a different course. But my focus in this course is going to be enterprise data, data that you own and control, and the potential for blockchain to help you with the maintenance and integrity of that data. When it comes to corporate data stored in a corporate database where you already have controls and replication and security in place, it's hard for me to see why anyone would throw that out for a distributed ledger. You certainly don't need to do that in order to implement and gain benefits from blockchain technology. So for the purposes of this course, I'll be using private blockchain to refer to a blockchain that can only be written by your organization. It's a private ledger where you control who can add new transactions. But, as you'll see, the blockchain itself will be distributed and public, while still maintaining absolute privacy over the transactions themselves. You might call it a private, read-only distributed ledger. I know that sounds confusing, if not impossible right now, but over the course of the next few clips, it will become clear. How to implement such a ledger in Salesforce is actually quite simple. From a technical perspective, you can build the ledger right on the Salesforce database, with a custom object defining the blocks. While distributed blockchains typically combine many transactions into a single block, in Salesforce you'll likely have a single block or record for each transaction. That way you can take full advantage of Salesforce's infrastructure for forms, reports, validation rules, and so on with regards to ledger entries. You'll see in the next module exactly how to build out this kind of private blockchain. We are, however, left with two critical questions. The first may already have crossed your mind. Salesforce already provides a robust set of security features to control access to records and excellent auditing capability. If you turn on field history, you can track record changes, at least for a time. So what possible benefit is there to implementing a blockchain? Why not just use standard Salesforce features to accomplish the same thing? Second, As you learned in the module introducing blockchain, it's not enough to have a blockchain, you need it to be immutable. It needs to be hard to tamper with the ledger, and it needs to be possible to quickly detect any tampering. Salesforce records are easy to create and edit, so we need a way to address those issues as well. You'll learn the answers to these questions in the next 2 clips.